Hello, this is Team 3. We are doing the analysis and redesign of a 3D printer. Our team consists of Sarah Searing, Cameron Miller, Osvaldo Serrano, Joel Honigford, and John Radke.
Okay, this is about the product description. Basically, this is a 3D printer using the FDM technology. And of course, this includes high accuracy printing, fitting smoothly, auto leveling, of course, stable movement, and of course, this use stepper motors. And you can see in the right side the entire assembly CAD image. And in the next slide, we're gonna show the exploded view of each component. And you can see we have some sub-assemblies. For instance, in the left side, you can see one of them. That is the stabilizers features for the table. And of course, we have a power box, and of course, the extruder assembly that is the main one in order to do the activity in the printer.
The primary customer is mechanical hobbyists who utilize the 3D printer for creating parts and models for their various projects. The secondary customer is generally rapid prototyping teams within an innovation division of a company. For the functional analysis, you can see our FAST diagram. The task function of the 3D printer is to create a project. To do so, the 3D printer must maneuver axes, prepares materials, and assures dependability. It also assures convenience, enhances the product, and pleases senses. It maneuvers axes by moving extruding plate and supporting extruder. It prepares material by feeding material, melting material, and cooling material. It assures the dependability by increasing precision, and it pleases senses as it appears aesthetically pleasing.
For the assembly sequence analysis, we made two different sequences. The one on the left, sequence 1, starts by assembling the framing, so the biggest component first. Then it does the inner component, which is the plate and the mechanism to actuate those axes, followed by the base fan assembly, and then the most complicated components and the smallest, the extruders. Sequence 2 sort of starts in the opposite with the most complex component, the extruder, attaches it to the frame, which attaches to the base fan assembly, and then the plate assembly goes last. For the sequencing table, we determined that sequence 1 fit the needs best, as subsequent subsystems can be attached in parallel, and the most delicate subsystems can be attached last, while sequence 2 assembles the extruder subsystem first, which benefits testing for the most critical subsystem.
Following is our bill of materials and our cost estimation. Our total cost came out to be $897.64. You'll notice that most of these parts are purchased. The reason behind that is just for cost efficiency. And looking at this bill of materials, there's a lot of room for improvement and to further improve the design and make it more cost efficient.
Here you see our function component mapping matrix. Across the top are the functions. Across the left side are the components. Inside the matrix are X's denoting which component aligns to which function. Here you see our quad chart classification. Across the top is the manufacturing cost, low and high, and the functional important across the left, also low and high. The top left is low importance, low cost, but it is a means for eliminating from our design. And then high manufacturing cost, low functional importance will also be eliminated. You'll see the Z-axis rod, frame guide beam, the linear bushings, and the cooling fan will be eliminated. We will keep as is the stepper motor, the NEWA 23 stepper motor, the stepper motor with the face plate across the top, the linear guide, block flange bearing, and the aligned pillow block flange. And then we will be redesigning with DfMA the extruder assembly.
Now Ozzy will tell us about the functional differentiation table.
Okay. Well, this table is referring to what exactly functionalities between both products that we are covering. Of course, remember that the first one is for the hobbyist and the second one is for company people. So as you can see, the big differentiation is about increase the precision. Of course, the material that it's going to handle will be different, and of course, some appealing things in order to make it better for home. And yeah.
For the component commonality table, on the left you see all of the platforms, and on the right you see our modules, including the extruder assembly, extruder plate, and cooling fans.
The product family design is shown on the slide. The primary customer desires a cheaper and more visually appealing 3D printer. So we are making the changes to a different printer bed or extruder plate and making that glass because it's more aesthetically pleasing to have in home. Removing cooling fans to decrease cost. Low output allows for this. And removing one of the 3 print bed stabilizers at least on each side to decrease cost. And again, low output of parts allows for this. The secondary customer desires to produce more parts more quickly. So we are increasing the size of the 3D printer, both the or all of the housing, platform, and extruder assemblies by at least 150% larger. This is to produce more parts more quickly and allows for production of larger parts depending on industry. A larger nozzle and increased speed of material feed to produce more parts more quickly, and a base plate sensor on the extruder or a coordinate measuring system to increase the print precision.
Here you see the CAD models for both the primary and secondary customers. On the right is the secondary variant. It's about 150% bigger than the first variant, which will allow for larger part printing and potentially multiple parts at the same time printing. It has cooling fans at the bottom for the cooling of those large parts, and it has additional supports on the sides for a larger extruder or printing plate. The primary variant on the left has a blue glass plate for aesthetically pleasing appearance and has less supports on the sides.
The following is our assembly sequence. As Sarah and Cameron just both said, they are both assembled the same until you get to the extruder assembly, extruder plate, and cooling fans. This is where both the models differ for the reasons that they both said.
Thank you all for your time.